All right, thank you all for coming to the room or to the connection, and those listening to you to us through the recording. Thank you as well. Belated. We have the pleasure to have with us Blaec Bejarano. Yeah, I think I said it right.
Yes.
Blaec has a master's degree in mathematics from Oregon State, and since became, well, 3 years ago, became the chief officer, sales officer at Sage Math, who's producing CoCal, which is a platform that will be presented today. If you want to talk to him, if you're in the room, we'll take questions later. We'll take questions from online. But if you're an astronomer who goes to AAS, Blaec likes to show up every single one of them and has his full setup and great demonstration. It's through such a demonstration that we met Blaec in New Orleans more than a year ago. And since then, we had the pleasure to work with him through USLTP. And yeah, so the floor is yours. Thank you again for coming today.
Thank you very much. So my name is Blaec. I'm very happy to be here on the Big Island, and I have to say that it's been a fantastic experience and glad that we were able to get this situated and was able to make it in to give a quick presentation. But today I'm going to tell you how to build a data science platform based on user needs, really from our own experience working on CoCalc, and also just give you a bit of background information on who we are. So we're Sage Math Incorporated. CoCalc is our platform. And I'll go ahead and head over here. Oops, there we go. So what is CoCalc? That's what we might as well get started there. So CoCalc's basically a real-time collaborative platform like a Google Suites, but for computational scientists. So they can collaborate in real time via their web browser, use any of their favorite programming languages or applications, Jupyter, Linux, LaTeX, Markdown, VS Code, all the things in a typical data science workflow. But we make it collaborative. We try and make your life easier when we can, but we also try and give that flexibility. So if you have that traditional computer science background, you want to be able to install whatever you'd like in the stack, or maybe configure things to meet your own needs for your workflow, you can definitely do that as well. But I'll go ahead and pop over to my CoCalc projects now. And just to give a quick look at this is our website, cocalc.com. We do have an on-premises installation for folks that have sensitive data requirements, or maybe they have a cluster of machines that they'd like to use. Those are all absolutely things that you can do. But let me head over here to my projects. So this is our hosted platform, but it should give you a good sense of the CoCalc UI. And this is running on our Kubernetes cluster on Google Cloud over on the US East Coast. And projects are essentially, they're virtual workspaces. They're actually Kubernetes pods that are running on our cluster. And you can have multiple projects with different sets of collaborators to determine who has access to what files from the file systems and what computational resources. So this is my own personal project here. And you can see this is a shared file system. It's actually a Linux file sharing system. And if I wanted to collaborate with you all, I would head over to my user panel and I would add your email addresses and you'll be listed. And then you'll have access to the shared workspace. And from here, we can create folders with any of our favorite open format file types. So you can kind of think of CoCalc as somewhat of an operating system, everything under the sun. I mean, Fortran's even listed here. So if something that's part of your regular everyday workflow is not listed, we want to know about it. And we want to make sure that we're supporting computational community the best that we can. But in addition to that, we support applications like Jupyter or Linux, LaTeX, Markdown. You can use traditional code servers like Jupyter Classic or Jupyter Lab, VS Code if you're a developer, Pluto for those Julia fans out there, and RStudio for the statisticians. And we do even support X11 graphical desktop for Vim, Emacs, Spider, your own custom IDE. And our company was born out of the University of Washington Math Department. So let me head over here. So William Stein, our CEO and founder, was a tenured professor at University of Washington until 2019 when he decided to leave and grow the company full time. So we have deep roots in academia. The four of us that run CoCalc, we all have backgrounds in either pure or applied math. And what I'd really want to maybe emphasize here is we're building based off of our own experience. And I think that that's something that can certainly be relayed to what you might be interested in doing to build a data science platform, using those subject matter expertise as astronomers to build things starting with yourself. And very likely those things that you build for yourself will be useful to other people in the community. So that's one thing that I'd want to maybe mention in terms of who we are and what we do. Right here, you can actually see at the very left, that is our CEO and founder, William Stein. Here is our Chief Technology Officer, Harold Schilly, who's in Vienna, Austria. our Chief of Operations, Andre Novoseltsev, and then here's me at the AAS meeting that was in National Harbor in this January. So really excited to have participated there. But the other thing that I'd want to, really kind of dig in here is when I say building based off of your own experiences, we're really talking about William trying to teach his own courses. And maybe just to step back a little bit, Sage Math is an open source programming language. It's actually a computer algebra system, and it's great for computational symbolic algebra. It's really an alternative to MATLAB, Mathematica, Maple, and Magma for those kinds of purposes. So maybe you've heard of Sage Math before, but William really wanted to use this computer algebra system that he built in his own courses. So he wanted students to be able to utilize this in anyone that's actually used Sage Math before, the open source version, knows that installing it can actually be a huge headache, especially in an educational setting. He wanted to get that 1 to 2 weeks back of his course where he had students coming in and out of office hours, trying to get everything configured on their own local laptop, dealing with a bunch of different operating systems. So he created CoCalc to really facilitate that process. And by the time that CoCalc was actually created, he had several other professors that were reaching out to him that wanted to be able to use the platform for those purposes too. And in fact, some of our first customers in California were utilizing the service directly from the server that was on his desk in his office. So we have lowly origins in that context, but we've came a long way. The platform's been being developed for the last 10 years now, as in the software itself. But like I had mentioned before, William left his position in 2019 because, the mathematical community, the computational folks tend to be the black sheep, and at least in the pure math community. So he felt like if he was able to leave, he would make a bigger impact on the community in general and be able to really try and build something to support the development of Sage Math. So that is, kind of who we are, where we come from in that context. The other thing that I maybe want to mention here too is CoCalc, the main difference between something like CoCalc when it comes to Jupyter or Linux, et cetera, is its real-time collaborative nature. So it really is like Google Docs. You can see each other's cursors moving around, see each other typing in the script in real time together. I'd mentioned that course management system that we had created in order to be able to use Sage inside of an academic setting. And then there's some other things called, it's actually a feature called time travel. It's personally my favorite feature in CoCalc because I tend to make mistakes while I'm coding and I want to see what I had changed that had broke everything and maybe just go and revert back to that previous version and build on top of that. And I'll give a quick demo of that here in a little while, but I wanted to make sure that I mentioned some of our early history and what was kind of developed based off of our own personal experiences. And maybe just to really allude to this, time travel really feels like standing over someone's shoulder and watching what they had done and being able to leave those annotated comments and feedback without being physically present. And a tool like that became imperative during the pandemic. And I think everyone had some kind of interesting experience when it came to collaborating online and trying to use Zoom, Slack, Overleaf, Jupyter Lab, GitHub, a Linux terminal, a data center. And CoCalc really tries to bring all of these things together in one convenient location. So that's one thing that I'd mention in that case. Oops. So let me go ahead and do this. So a pipeline for support and user requests. So this has been fundamental to our growth as a platform over the last 10 years. We make it really easy for the users of the platform to be able to come leave feedback and request software, in fact. So maybe here I'll even just go ahead and pop over into our help system. And you can see anytime that you're inside of the platform, you can just click on the upper right-hand corner on help. And then you have the ability to create a support request. And you can ask for a task. Hey, CoCalc could really like to have this software for my teaching or my research, and then we'll test it, give us a test file. We'll test it, import it globally for all of our CoCalc users. And we've been doing that for the last 10 years now, which is why we have one of the largest fully maintained stacks for languages like Python out there today. And then also you can chat with us. We tend to be very communicative, and I think some of the folks here can attest to that, but we're always happy to have a video call and see what you guys are up to. And like I had said, while we have backgrounds in math, we really can try and connect through those means to any kind of computationally oriented community, including the astronomers. So we're very happy to be here in interacting with you guys in that capacity. But that is what I'd want to mention in terms of support. And let me head back over here and say, the other big part of my job personally, my role for the company, is listening to the community and engaging. So I think this next month I'll be at the Society of Industrial and Applied Mathematics. It's the Computational Science and Engineering Conference that they host every 2 years. So I'm really excited to be back there. I was actually a student chapter secretary for my local SciEm group at Oregon State University. So I'm always happy to be engaging with that community. but that will be my 60th conference since I'd started working for CoCalc. So I'm literally everywhere, including here in Hawaii right now. So don't stop me. But yeah, I'm super excited to be back out on the road and to continue my conference tour and to continue listening. And I mean, I think that's honestly one of the most important things that we do is really hear out people on what they're looking for in a data science platform, what's missing, what are some of the gaps that we can fill, what are some of the convenience factors that we might be able to really help smooth over for their workflow. So that is one thing that I want to mention in that capacity. And like I'd said, always doing video calls and soliciting feedback via email. And you might have very well received some email cadence from me that said, hey, we'd really like to reconnect with you and get some of that feedback and make sure that we're on the right track to continue developing the platform in the right way. And honestly, this feedback has been fundamental in paving, our development cycle and in our development path. So we're continuing to do some interesting things, and I will make sure that I relay some of that here very quickly. And again, some of the products and features that we've literally created from feedback would include our software stack. And I can even just go over here. Let me go to software, and you can see that there are executables and Python libraries, Sage math packages, R statistical packages in Octave, Julia. So you have a whole range of different programming languages with the pre-installed libraries. So anything that you should need will likely be there unless it's very niche or very new, but you can always pip install anything that you'd like as long as you have a CoCalc license or you're using on-premises installation. But here you can see that we have almost 2,000 packages that are immediately available for Python right out of the box without installing anything. So that is one thing that I'd want to mention in that capacity. Another thing that I'd want to mention too is CoCalc on-prem. And CoCalc on-prem was really the result of interacting with a load of different customers that really liked the platform and liked the UI and the convenience that it brought, but they were unable to use the platform because they have sensitive data requirements, they have machines that they want to use, maybe they have a cluster. That is really kind of why we developed the CoCalc on-prem product. And the other thing that I'd want to mention here too is payment system flexibility. We work with a lot of academics and we're starting to work with some laboratories, et cetera. In fact, I just met with some people from the Department of Energy and the Department of Defense, and they want to be able to use CoCalc on-prem, and they needed some the utmost flexibility with what's going on right now in the country to be able to utilize the platform. So we're always willing to work with people on that. And in fact, just this last year, we've completely revamped our entire payment system to make sure that we're meeting the needs of our customers and our users. The other thing that I want to say too is internationalization. CoCalc is used all over the world. I couldn't even name a single country really that doesn't have someone that's using CoCalc in it. So internationalization in terms of using the UI. In fact, I can head back over here and go over to my CoCalc project. And you can see under the account settings, you have the ability to choose from a variety of different languages. And artificial intelligence has definitely made this kind of thing easier for data science platforms. So we were really excited to jump on board with that. And realistically, since we've done this, we've seen a huge uptick in the amount of usage from neighboring countries and folks that aren't, native English speakers. So that is one thing that I'd want to mention in that sense. And the other thing that I could mention too is compute servers. And again, our origin stories are in academia. And you might think of that as, hey, there are a lot of toy examples that you'd want to code in Python or Sage Math to do some mathematical explorations or some data science. But nothing particularly interesting was possible until literally the creation of compute servers, which allows you to spin up arbitrarily powerful VMs, major CPU usage, or even some GPUs if you need those. But this was a result of really interacting with the scientific community throughout my conferences, actually. And I was the main advocate of this particular feature in the platform. And I'll make sure that I demo these things too. VS Code, Jupyter Lab, RStudio integration, just making sure that we're moving people where they're at. Use the UI that you feel most comfortable with, whatever you've grown on throughout your educational experience or throughout your career. But then you can easily compare results and write publications with other folks on your team that maybe have a different niche workflow. AI integrations, we were very quick to actually fully enable and integrate AI. And the funniest thing about this is I will just make a quick mention to the ability to disable AI integrations was a quick follow to that. And that was actually a direct result of interactions with the University of California, Los Angeles, who is our largest customer. And they were trying to navigate in the middle of the AI explosion, how they're going to continue teaching courses, making sure that people are getting the information that they need out of the course without just generating everything and really just diving down that path. So I will show a couple things in that capacity as well, some course management related functionalities. And then again, from the pandemic, it came a lot from listening. People were looking for a really convenient way to use a whiteboard functionality that also allowed them to run code cells and have a conversation about any of the open source programming languages that CoCalc provides or supports. And then also some publishing capabilities that we support Cambridge University Press for the Journal of Fluid Mechanics, as well as graduate texts like Intro to Python for scientists and engineers. So there's some really neat things going on in that sense. But I'll make sure that I demo some of these things right now. So the first thing that I'd really want to show is compute servers. And inside of the CoCalc UI, what I can do is I'll head over to my project. And you can see from my file system, let's say that I'm working on a Jupyter notebook, or maybe I'm working on a .py file and I'm just running things through the terminal, but I'd like to give it the juice. I want to run this script on a really powerful machine as opposed to the shared resources that CoCalc provides. We do have a limited cluster. We can only provide so many resources to any individual that comes to use our hosted service. So what we've done is we basically were able to use the compute server functionality to farm out the compute to some of the major cloud providers, and you can even connect to your own local resources. So let's say that I'm working inside of this notebook. In fact, I just made this cool little map of the observatory right here, or the base facility for the Gemini lab. So let me go ahead and head up here. And if I was running the script and I would like to use a more powerful machine to run this on, I would click on the server button. And from here, I can use a compute server that I previously created, or I can create a new one. And at this point, I can choose from cloud providers like Google Cloud or HyperStack, self-hosted, meaning my own local laptop or server, or maybe I want to use my own cloud provider. Maybe I want to use AWS and I was given some credits and I want to use those there. Or maybe I have some bureaucratic constraints and I have to use Azure or I have to use AWS. So we make sure that we support those folks too. And we should have some other dropdowns that will be listed there in the near future. So we're really excited about that. But I'm just going to use Google Cloud as a quick example. And you have spot instances, which are great for batch processing. You can use standard instances for a production level workload. You want to make sure that machine never shuts off no matter what. But the spot instances are great because you can see here that you can get up to an 86% discount when you're using those. In fact, I'm pretty sure that's what Google Colab uses in the background, is some of the spot instances from Google. But if you need a GPU, you have the ability to choose that, the GPU type, the number of GPUs, and then you have the official NVIDIA Docker images for machine learning software like PyTorch, TensorFlow, Google Colab, Llama, CUDA, and JAX. Similarly, the machine type. So you can choose the exact machine type that you'd like to run with a GPU. And then underneath this, you can see the region. So where is that data center physically located? What's the cost associated with the exact location, and where you have lower carbon emission rates? So again, you can meet whatever bureaucratic constraints or technical constraints that your organization has to contend with. I need my data center to be physically located near me to reduce latency. I need my data to be located in the United States or the EU. You can make sure that you meet those requirements by choosing the compute server of your choice. And then there's some really nice additional features like persistent disk storage. You can enlarge the disk at any time. You can actually choose the exact kind of disk that you'd use and be able to modify the price there. And you can even use a custom subdomain with an SSL certificate. So unlike using cocalc.com, which is running on our cluster, we obviously can't give root access or sudo rights to our own cluster. But when you're spinning up your own machine from Google Cloud or using one of the compute servers on any of the other cloud providers that we support, you actually do have root access and sudo rights. So you can apt-get install anything that you need. You can fully configure the environment and really interact at a lower level with that machine itself. So that is one thing that I'd want to mention there. And in addition to that, you can allow collaborator control. So let's say that I wanted to add one of you to my CoCalc project to be able to run some things with my script. And I want you to use my compute server, but I could have the billing come to me. So that way you're not feeling bad about sending someone off the deep end to go put in their own billing information and start spinning up servers. You have the ability to control that. And I will mention a very neat aspect that we've recently introduced here in a little while with compute servers in our course management functionality. So I'm really excited about that. But yeah, that is our compute server functionality. And similarly for CPU machines, you have standard scientific software images. So those are all the Docker images that we support here. And you can, of course, use your own custom Docker images as well. Machine type, everything from the smallest E2 micro instance for a fraction of a penny per hour, some really just great value machines, up to just the most massive machine you'd ever probably want from Google Cloud, with almost 12,000 gigs of memory and 416 CPU cores. So HPC is definitely possible now inside of the platform. You can run on just one really massive machine, and you can see, you know, for such a large machine, I mean, the price isn't so bad. In fact, there are actually some comparable machines that are quite a bit cheaper as well. So I would just want to maybe point that out. And when you spin up the compute server, it will be listed in the dropdown, and you can access that from your notebook or from your terminal. And then if I click here, you can see now it would be running on this if I went ahead and actually started the machine. I'm not going to do that right now, just for purposes of time. But you can see here that is now running on your own dedicated virtual machine on that compute server of your choice that you'd fully configured rather than on our Kubernetes cluster. So that is one interesting feature that I would want to mention in terms of listening to the community, building based off of user feedback, and really trying to meet people with, where they're at when it comes to computing. The other thing that I'd want to mention here too is we recognize, so we built our own Jupyter Notebook interface. You might have just seen that Jupyter Notebook and said, hey, that does not look like Jupyter Lab. And you know that is absolutely true. The one thing that I'd want to mention about our Jupyter Notebook interface is that it is real-time collaborative, just like Google Docs. You can see each other's cursors moving around. You can see each other typing in the script in real time together. Every document also has a side chat functionality. So you can call each other over and you can say, Blake, check out what I've been up to today. Leave me some comments and feedback, contribute directly to the script with me in real time. There's large language model integrations with GPT, Gemini, Mistral, and Claude. And we use an on-premises installation. You can actually use a self-hosted model of your choice. So maybe you're not allowed to use GPT or Gemini, et cetera. You can actually self-host a model, an open source model for that matter. And you can kind of plug that in and be able to utilize it directly from the CoCalc UI. The other thing that I want to maybe just quickly mention here too, since we're sitting right here, is when you interact with the language models, since CoCalc is a computational platform, you actually have the ability to generate code and test it directly inside of the side chat. So I'm going to say, create me a script that plots the, let's say, wave equation in 3D using finite differences. My math background's coming out right now. And give the LaTeX equations in dollar signs. So let me go ahead and do that. And I'm going to start a new thread. Hide this. So now you can see it's actually going to generate my code, and it knows that I'm using the Python kernel inside of the notebook. In fact, there are a whole host of different kernels that you can use. Python, R, Julia, Octave, C++, JavaScript, Macaulay 2, Rust, you name it. And you even have version control for the kernels themselves. So you have that one pesky package that's only running with Python 3 Anaconda 2022. You could just select that kernel and you're off to the races. You don't have to go deal with any of those package dependency issues. I'm going to go ahead and move this back to my home base. So let's do that. But you can see it actually did create a cell. Where's that at? Did I ask? Let's say. Let's do that one more time. Create me a script that plots the 3D wave equation and give the LaTeX in dollar signs. Let's do it. So you can see it is going to generate this here. In fact, I actually generated this nice little script earlier for the map. And there we go. Is it going to do it for me? Is it an internet problem? I don't know. I don't think so. And let's try a different model maybe. There we go. So that was an OpenAI problem. So you can see that I have my nice little script that's using Python. And here is my LaTeX equation. And I can actually click run directly inside of the side chat and make sure that my visualization shows up, that I'm getting the numerical results or the plot that I would expect before I port this generated code over to my production level notebook on the left. So now I'll go ahead and I will click copy, paste it. And maybe I don't understand everything that's going on here since I just generated it. I can explain, ask, get a nice little overview of the underlying architecture of the problem, what each of the variables, components, and packages do. And the other thing that I'd want to mention here too is if I break it, I'm going to run this guy now. It'll say, help me fix this. You wrote plot sow, not plot show. Here's the corrected version of your code. And everyone has that colleague that loves a different programming kernel syntax. So you also have the ability to easily translate and say, hey, I want to translate this to another kernel. And maybe I'll go ahead and I'll translate this to Octave. It's kind of ancient, but sure. So here is Octave, and I have my code. And I can even run it using the Octave kernel again directly in the side chat. Have a more fruitful conversation with that colleague in the syntax that they feel more comfortable with, rather than having to kind of send them off the deep end with my code. The other thing that I'd want to mention here too, you can video chat, you can split your screen, look at multiple portions of your code. Maybe you want this to be a terminal. You could push, pull, commit to your favorite repositories via Git. You can use any of your favorite Linux commands. But in addition to version control via Git, we have that time travel feature that I was mentioning earlier. And really just to highlight this, I'm going to handwrite a couple lines, and maybe I'll say something like, I don't know, intro. And I'll make a line. And then maybe I want a little bit of LaTeX. So here I'll say sigma minus nu is equal to gamma. Oh, oops. Sigma minus nu is equal to gamma. Okay. You can see I have this nice formatting here. And then just to really, again, emphasize this, and you'll even see my mistake, which will also be great. So here I'll say B minus A. All right. So in addition to version control via Git, of course, you can push, pull, commit to any branches that you'd like. But not everyone will or should have a traditional computer science background that's doing applied computing these days. That's, if there's anything that I absolutely believe, it's that. And version control is important for everyone. So I think that this makes version control much easier, which is why I am personally a huge fan of the time travel functionality in the platform. But you can visually rewatch the script be created over time in fine-grained resolution. In fact, if I stop typing for 0.75 seconds, it records a new revision to the revision history. And then I can say, oh, hey, Blaec, I really like what you were doing here up to revision 66 out of 77. Let's go ahead and revert back to that previous image, build on top of that. And if you're really lost in the weeds, you can't figure out for the life of you what went wrong where, you can even use change diffs to see exactly which changed in JSON format between any 2 points in time with syntax highlighting. And then you can iterate throughout the document in that sense too. So there's some really nice collaborative features and version control features that are provided in the platform. And the other thing that I'd want to mention is that if this file happened to belong in a GitHub repository, there's an additional checkbox that says Git, and then you can look at the commit history of the document over time in the repository and see who's made that commit. So that is, I don't want to say Git blame, but it is somewhat like that. You can definitely see who's made what mistakes and be able to iterate on that. But definitely from like an educational standpoint, this has been invaluable for us, especially for academic dishonesty and seeing whether or not someone was using OpenAI to generate the answers to their assignments. Or maybe you just want to be working with some folks that are research colleagues, and you really want to see what was the mindset and process that you went through while you're developing this. So this can certainly help show what had happened while you were away. Maybe you have someone that's working in a different time zone. I know that's definitely a huge thing with Nora Lab. You guys are located everywhere. So if you're waking up in the morning, you want to see what's changed while you're away, you have the ability to do that via time travel. So that is one thing that I wanted to mention in that sense. The other thing that I want to mention too is our whiteboard and slideshow capability. I just think that it's really awesome and it's fun to use. It makes taking notes and doing computations fun with scratch work, and have a real conversation about the math and the code right next to where you're implementing it. So I'll go ahead and dive into that really quickly. So let's do that. I'll go over to my file explorer and go to my demos and whiteboards. So here is my whiteboard. So I love CoCalc. And you can see I made some sticky notes, and here's our rich text WYSIWYG editor. So you have the ability, if you're not familiar with LaTeX or Markdown, or you just want that convenience to be able to use a rich text editor, you can do that as well. But here's Markdown with LaTeX compatibility, which I'd shown a little bit in the side chat earlier if you didn't catch that. But here is that. But more interestingly, you can run Jupyter cells using any of the kernels that I'd mentioned earlier directly inside of the whiteboard. So, and it's the same thing with the slideshow that I'm actually using to give this presentation right now. But you can click run, and you'll see the results show up, and it's using the kernel. But that is one thing that I wanted to mention in that sense. So let me go ahead and hop back here. And then also our publishing capabilities. So this was really listening to existing customers and building based off of their needs. And I really like this functionality. I think reproducibility is certainly a hot topic right now in the computational community. People need to be able to easily reproduce results, especially as data-driven decision-making becomes more apparent in everyone's day-to-day lives. So this is huge. And we want to make sure that we're on the forefront of exactly that. So we do partner with Cambridge University Press to host the Journal of Fluid Mechanics, as well as graduate texts like Intro to Python for Scientists and Engineers. And just as a quick little example, I'll go ahead and show the Journal of Fluid Mechanics, since I'm sure that there are people that are interested in fluids in the astronomy community. But here you can see cambridge.org. I'm reading through the journal and I see a simulation. It looks relevant to my research. And I say, hey, this looks great. I really want to try and modify this for my own research purposes. You can click on the hot link directly next to the plot that you'd like to utilize. And this will take you over to the CoCalc share server. And now you have access to the Jupyter notebooks and datasets that belong with the research publication. You can edit your own copy, pull it into your existing CoCalc account. You can actually use it anonymously as well. The other thing that I'd want to say too, though, is you can open up those notebooks and you can just download them locally and be able to run them in your own environment. So you don't have to use the platform. And everything inside of the platform is also, I want to make sure that I emphasize this, open format. So you can always download things out and use them elsewhere. We just want to make collaborating more convenient, but we certainly don't want anyone to feel like they're hemmed in because we don't like that either. So, but you can see here's that nice little visualization. And we even support 3D fluid dynamics for the journal. So here's a nice little simulation here. This will be my last one to show. And it'll take just a second because it's somewhat computationally intensive. And here it is. There we go. And this is quite a nice little plot. And you can see that this is some vorticity with some fluid density inside of this cube. But this is just a nice example of reproducible results that I'm not having to pull the repository from Git, configure the environment, compare the results, and then modify it for my own purposes. I skip that entire first portion of that process and I can get right to utilizing the results that will help me with my own personal research needs. So that is something that I wanted to make sure that I mentioned in that capacity. Now I'll go ahead and head back over here. And now I want to dig into, again, VS Code, Jupyter Lab, RStudio integration. If you're working inside of the platform and you do not want to use our Jupyter Notebook interface, and there were lots of folks that said, hey, I already was trained on using Jupyter Lab. I feel much more familiar with that user interface, and I would really like to be able to use that. Is there any way to be able to do that? And the answer was yes, because it's open source. We certainly can do that. So you can go to servers, and you can actually just click on the notebook server of your choice. So if I click on Jupyter Lab, this will launch the traditional Jupyter Lab in a separate tab in my web browser with the same shared file system. So I can easily use that CoCalc UI without necessarily, or I'm sorry, the Jupyter Lab UI with the same file system. So I'm not feeling like, again, I'm hemmed into using any particular tools inside of the platform in that sense. And while this is going to take a second to launch, I can also do the same thing with Visual Studio Code Server. So let's see. In fact, I'll leave that alone for now, and we'll come back to that. Oh, there we go. So here we go. And this is, again, the traditional Jupyter Lab that everyone should hopefully be familiar with here in that context. So, and then you'll also be able to see the my actual directory from inside of my CoCalc project. But there we go. And similarly for VS Code, go ahead and click here. Here's the traditional VS Code server with all the extensions that you know and love from the ecosystem. But again, with that shared file system over on the left-hand side. So that is what I'd want to mention in that capacity. And similarly for RStudio and Pluto notebooks for the statisticians and the Julia fans out there. I won't go ahead and dig into that, but I will hop back over here one last time. And then I wanted to mention, I think the funniest thing about AI integrations, I know that I'd shown some of that, but the funniest thing to me about our AI integrations was we've really made, I think, more revenue from the ability to disable AI integrations from an educational standpoint than from actually utilizing the language models. So while we definitely are AI first in terms of just trying to give convenience to using the language models, we support all kinds of customers that really deserve to have that flexibility for their course or for their research or any kind of project that they're working on. And everything that you're sending to the models in CoCalc is explicit. So that is one thing that I want to mention there. It's not going to auto-complete anything for you or send things randomly to one of the language models or the providers. But here, I just want to show inside of the settings panel, you have the ability to disable this underneath preferences. You can scroll down and you can see underneath the AI, where's that at? AI settings, disable all AI integrations, and then you can also set default languages, etc. And then for the course management system, so I'll go ahead and hop back into my project, go to my course. So here's just an example course. And underneath the configuration panel here, you have the ability to either disable all of the AI integrations or some of the AI integrations. And some being, you can allow, explain this code cell and help me fix this error, but you can't allow full-on prompt engineering over in the side chat to be able to solve various examples or assignments. So that is one thing that I'd want to mention there. But our course management system is very flexible. It's also great for workshops. So that's the other thing that I want to mention. So if there's anything that you guys would like to explore in the open source ecosystem, this is in fact what some of the folks at the Department of Energy and Department of Defense are, that some of the national laboratories are interested in. They would really like to be able to use CoCalc to facilitate software demos internally for their own purposes. So we're really excited to be helping support them in that. So that is one other thing that I'd want to mention in that capacity. And here, just to give you a little quick sneak peek at the UI, you can see you can add students or workshop attendees via common delineated list or copy and paste a CSV file column, and then they'll all be added individually here. You can see I have some little test students, but they're actually just my alias names here. But you can see I can assign a particular assignment to them. I can also edit the student. In fact, here are the assignments. So you can choose the assignment folder that you'd like to distribute out to the class. So you choose the assignment and it will be listed. And then you have the ability to assign to a particular student in the workshop. You can open up their own copy. And what's really neat about this is when you add students, this creates a private student projects for each of the students that are listed. And then you can actually click open, and this will open up the students project, and you can edit the copy that they've received inside of the course or inside of the workshop. So you can leave annotated comments and feedback directly for them, and they can use the chat system, and you'll receive mail notifications that let you know that someone had called you over. So that's one thing that I want to mention in that general sense. The other thing that I want to say too is handouts. And maybe more importantly, you have the ability to install things for all of the workshop attendees or participants at once via a terminal command. So that is one thing that I think is kind of interesting in that sense. So lots of these functionalities you can see were built out based off of our subject matter expertise and our experience teaching at University of Washington and my experience at Oregon State University. But copy missing handouts and assignments for those students that showed up a week late and you've already given out that person assignment in syllabus. Reinvite the students that said that they never received that email invitation to join the platform. So those are, and of course, export grades to Canvas, Blackboard, Moodle, you name it. But those are all available as well. And this was really kind of built based off of our experience in teaching. And then lastly, a shared project. So you have an optional shared project where every student or workshop attendee is added as a collaborator inside of a shared project. And then you can all collaborate together inside of chat rooms or using the whiteboard, Jupyter notebooks, etc. But you can have up to 50 people inside of the same notebook. I don't know why you'd ever want to do that, but that's about the limit at what you can do there. But I wanted to make sure that I mentioned that too. So that's probably enough of some of the demoing there. And what is next for CoCalc? So we're not doing anything that is particularly like feature related right now. So I wish that I could point that out, but we are doing some performance enhancements to the platform right now that will certainly affect the hosted platform as well as the architecture for CoCalc on-prem. And this really has to do with NATS and Ceph. So we're really excited about this. This should hopefully make that, I think you've probably seen that connecting sign there for a minute when I was starting up my project, should make that much more smooth and allow you to have access to the files before you actually start the project itself to be able to run computations for a notebook or using a terminal. But you'll be able to navigate and also edit the files without necessarily having to connect to that project. The other thing that I want to say too, and this really came from listening, and in fact, we've had several customer calls over the last 2 months about an engagement overview for how do I know who's actively working inside of the project, whether that's from like a research standpoint or maybe from an educational standpoint. How do I know, who's been active in what files recently? We do have a project activity log, which certainly helps with this. But more from like an educational standpoint, like how long were students interacting with notebooks, or how long were they necessarily, engaging with the subject material. So that is one thing that we've been working on and trying to identify metrics, and it's taken a lot of listening. Everyone has a different idea of what it is that they'd really like to do in that sense, but I think giving people flexibility, and you'll notice that all over the place in CoCalc, we try and give people flexibility wherever we can. And I think that goes a long way when it comes to building a data science platform, because it allows you to take something that you have to put development effort in and really reach a wider swath of the community and be able to make a bigger impact for those development hours, especially when you have a small team like ours. There are 4 of us. We were all on that first slide earlier. So I'd want to make sure that I mentioned that. But we also have a really fantastic LaTeX editor for publishing. And I will just give a quick look at that right now. And then some marketplace listings for some of the cloud providers like AWS. We're just about to be listed on Google Cloud. And then I am still working on making some good relationships over at Microsoft, but we hope to be doing that here pretty soon too, especially with everything that's going on with some of the relationships that are being developed between federal institutes and federally funded agencies and some of those cloud providers. So we want to make sure that we're on the forefront on that side of things. So let me go ahead and hop back into my project and give a quick look at the LaTeX editor really quickly. So if you're writing scientific publications, you have a very nice way of being able to do that. In fact, I'll click on getting started. And here is a couple LaTeX examples. And one thing that really sets our LaTeX editor apart from something like Overleaf is the fact that CoCalc is a computational environment, which means that you can run kernels directly inside of the LaTeX source. So you can see here, I actually created this little template. And I use the package Python tech. So you can see use package Python tech here, begin PyCode and end PyCode. In fact, here's the portion for the figure. And this actually will, in fact, if I build this, you'll see that it's going to run LaTeX right now. So it's actively running LaTeX, it's running Python tech, and then it'll produce the plot directly into the PDF. But here, maybe just to give an even better example of this, I'm going to generate a brand new LaTeX document. And I'm going to use GPT-4o Mini for that. And I'm going to choose an example. So maybe here I want to have an article for IEEE. So let me do that. And I'm going to say, create me a LaTeX template that talks about the relationship between neural networks, deep learning, and functional analysis in the context of physics-informed machine learning and applications to astronomy. Give relevant equations in $ and use Python tech to create an example plot. Okay. Now I'm going to, and I might even want to use a different model for this. So let's try Gemini 1.5 Pro, or let's use GPT-4o. Yep. Okay, so I'm going to generate this new LaTeX document. And you can see that it's going to generate right here. So I can actually check it out before I save that document. I don't know why it says it doesn't like my abstract, but that's okay. And underneath here, you can see here's my LaTeX and here's my figure. It looks pretty good. Go ahead and save it. Let's see, use Python tech. And this should be PyCode. And PyCode. Okay, I'll build it one more time. Hopefully it works. And you can see right now that it is running some things. And there's my nice little example plot of the sine wave that is directly inside of that LaTeX source. So when you share that LaTeX source to one of your colleagues, they actually have that code that belongs directly with it, and they can modify it. And you can also modify it without having to save those images in an external file, port them over. I was certainly never a fan of that process myself. So hopefully that will make things a little bit easier in that general context. So I wanted to make sure that I mentioned that too. The other thing that I would want to maybe quickly mention, oops, let me go ahead and do that, is me hop back over here. And I did not mean to do that. Let's go ahead and head over here to the log. So this project activity log could certainly be helpful for identifying who's been active in what files over time. Again, while I was sleeping last night, who is working on what files and what should I go check out and what am I going to prioritize in that context? So I wanted to make sure that I mentioned that as well. And similarly, underneath settings, you have the ability to add API keys, use SSH keys. You can use SSHFS, Google Cloud Storage, Amazon S3 buckets. I know you guys tend to have a lot of data. So if you have that data that lives somewhere and you want to be able to mount that data, you can do that in any of your preferred ways. Of course, you really have the full flexibility of a Linux terminal, and I should not leave without making sure that I demonstrate that, because we've done a lot of the development of the CoCalc platform itself inside of CoCalc. And I think that that's something really important to mention. In fact, our CEO and CTO are probably working right now. I can see some messages that are going on, and you can see I've been on vacation over the last week too. So that is one other thing that I want to mention with all of my my messages that are right here. But you have the ability to see who's been active and what messages have been sent, et cetera, in that capacity. So let me go ahead and close that. I'll go into my demos, and this will be my last little show. And let me go ahead and do, okay, that is not what I wanted. I wanted to go to getting started. Okay, terminal example. And here is a Linux terminal. And I'll go ahead and clear this. So again, you can see you have that full Linux terminal. And maybe here I want to use Python 3. And I'm going to use my Python example. So there's that. And you can see that it said, hello. Here are the first 10 Fibonacci numbers in the sequence. The other thing that I'd want to maybe mention here too, let me go ahead and clear this again. Oops. And I'll go ahead and say ls. Pretty sure I just write Julia. And then I'll use this little Julia example for those fans out there too. I know that Julia has been becoming increasingly popular in the high performance computing space. Well, I must be using the wrong command. What is it? I am personally not a Julia user, but again, I have my favorite assistant right here. What is the command to run Julia via terminal? Okay. And again, it is just lowercase. So I was pretty close, but no cigar. All right. So Julia, and then here's that Julia example. And there we go. The sum of squares for the first 10 natural numbers is 385, if you ever wanted to know that, but it works. And I have this nice, and the other thing I would want to mention here too, lastly, is that our Linux terminal is real-time collaborative. Every person inside of a CoCalc project is treated as the same Linux user, which apparently is very different. In fact, our CEO who'd created this, he had no idea that that was very different until he had already made it and said, oh, wow, I did something that was kind of unique in that capacity. But it's been very useful in terms of being able to kind of have that eye over someone's shoulder while you're inside of the same terminal, being able to run some commands, show what's going on in that capacity. So that is one thing that I'd want to mention there too. Let me go ahead and I'm going to leave the last 10 minutes or so for questions in case anyone has anything that they'd like me to dig into. But here is my sincere thank you, and me snorkeling with my girlfriend in the sea turtles over on Black Sand Beach yesterday, actually. So that was fantastic, and what a beautiful island, and what a fantastic opportunity to engage with your community. So thanks again very much for your time, and appreciate you. And I'll take any questions that you might have now. Okay.
Thank you
So
very much.
before we take a question, can I just comment about something? So so the USCLTP program, we've been working trying to reinvent the wheels, and we met Blaec at AAS, and I was like, no, this is not possible. This is not true. They didn't do that. So I remember taking our director, Pat McCarthy, to meet Blaec. And the first things Pat say is, so I heard that you're going to solve all our problems, and I just need to write you a check. So, and you were so nice with Pat. And we did write a check, so you do know. We did write a check, and thanks to CoCalc, we are really able to showcase what we are trying to do for the users, for the ELT that we provide all of this. They are the next generation. They don't want to waste time. And CoCalc really helped us as 1 year ago on our first NSF review. Our NSF officer loved it. Everything was nice. And since our team, especially Mike Fitzpatrick. Mike, if go talk to Mike if you want to learn more. Mike spent time, he installed Dragon running in it, going to the Amazon archive, taking Dragon data, reducing Dragon. And in our next review coming like in 1 month and a half, Mike managed to have the pre-pipeline on the model data from the iris for the TMT running in it with the TMT team working with it. And he also was able to show like you can access the data lab and the Ruben Science platform in a browser. I didn't even know your browser running. It's like, it's an entire computer. So Micah did a tremendous work to see how can you go, the entire lab can get together. And thanks for your time. Thanks for that. And we really appreciate this. So this is the future, at least for us in astronomy, when we've been. I was planning to buy a new computer to do my science separate. I ditched the new computer just have a Coca account.
No need to focus at your feet when you have the ability to focus on the application, and that's certainly what we want to try and help with.
Especially the collaborative part. I mean, that's what's missing everywhere, and how easy it is to bring people with different expertise in a scientific project, and because you cover everything, and that's what I wanted to comment that before we.
Thank you very much. And the last thing I didn't mention actually is that our Jupyter Notebook interface is actually stateful by default. So unlike maybe Google Colab, et cetera, you don't have to re-import packages every time that you close out of your web browser and you come back. And I think that is a huge time saver, actually. I've found that to be one of the huge contention points with folks that are using things like Google Colab right now. So we're really excited to continue working and listening. And honestly, that's why we're here. So we'd love to get some feedback if we can and see what we can do to continue enhancing the platform and meeting the astronomy community's needs.
I want to say,
write all our STI paper through
I want to say we have even more people online than on site. So I'd like to take one question online if there's one. If not, we can go back to online after a first question on site because I know there's a few already. So I'll start with one question on site. I see you have your hand up.
Yeah, thank you for introducing this really definitely platform that had a lot of notes in it. We're all very excited for it. So one special feature that you mentioned is turning off the large language model. So I'm very curious about it. Say a student is working on a project where they use some sort of VS Code with Olama, which is an open source large language model kind of manager. And then they generate some code, not entirely understanding what they're doing. They put that code into the co-help Jupyter Notebook. Would like the platform be able to tell the differences between a student who wrote the code or they're assisted largely by other external?
See, this is actually a really fantastic question. And we'd met with UCLA last week and they had this exact same question. And they said, hey, we would really like to be able to identify which chunks of code are likely to be pulled from somewhere else. Maybe they just go to OpenAI and they start generating code there, or from VS Code, like you had mentioned, and now they're copy and pasting directly into the platform. What constitutes like what you would expect to be a pasted portion of code inside of the notebook from maybe a previous assignment versus a pasted version of code that maybe came from elsewhere that is solving that assignment itself. So one thing that I can say is time travel is fantastic for this, just to be able to see, okay, there's this huge chunk that comes right away. If you are handwriting anything, like I said, if I stop typing for 0.75 seconds, it records a new revision. And you'll see that maybe, 50 line monster that comes out right away and you say, oh, wow, okay, that's definitely, someone that's using a language model, and maybe I should go and ask some questions and make sure that they actually understand what's going on there, et cetera. But we are developing this right now for that engagement mode and making sure that how long have you actually spent physically inside of the notebook, typing and engaging with that subject matter. It's highly likely that you would have less time that you'd spent inside if you just went and generated something elsewhere. But there are a couple other metrics. And if you have any ideas on what you would like to maybe see in that sense, we're all ears. And as we're building this, that will really help inform our development of that engagement overview, specifically for like an educational standpoint. So
yeah, don't give them all the tricks because now they'll develop ways to go around. Are we ready for a question online?
Someone want to raise their hand? I have a question.
Yes.
It is more on a practical side. there are advantages to have your own machines because once you set up your own, like for a specific problem, you can have your own machine and then running.
Yeah.
And what is roughly the cost difference between having my own machine under my desk and running whenever I want, or having all the fancy features there to run a problem that can run on my own machine?
So it's really nice about, and I'm glad that you mentioned this. So I kind of glossed over this very briefly, but with the compute servers, you actually have the ability to connect to your own local laptop or server. So if you spin up a virtual machine underneath your desk, there's no cost that's associated to this. So you have the best of both worlds in that sense. So maybe I need more resources than what's sitting on that server underneath my desk. Then you can farm out that compute to one of the cloud providers, but you can also just go ahead and select the self-hosted version. And what's really neat about this architecture, it's all actually outgoing connection from that server sitting underneath your desk via WebSocket. So it's all outgoing from that server to your CoCalc instance via WebSocket. And then you can collaboratively utilize those resources sitting underneath your desk from anywhere that you're at. So you don't even have to be home to be able to use that server sitting underneath your desk. So that is one thing that I'd want to mention in that sense. The other thing that I'd want to say too is if you're collaborating with folks, and you have that setup that you're mentioning that's for this specific problem, everyone's that you're collaborating with is going to have to go and set up that exact same configuration and probably be able to reproduce some code or be able to collaborate. You can do that here as a single Linux user and do the installation and make sure that everything's configured appropriately inside of your CoCalc project, add those folks as collaborators, and they're immediately off to the races using the software without going through that same process themselves of having to go and install and configure the environment to be able to run the code. So that's one thing that I'd mention from a collaborative perspective where you can really get an advantage there. But you can use those resources if you'd like. And then similarly with the CoCalc on-prem licensing, maybe you have a cluster of machines that you want to be able to use, and you've already made this investment into a hardware infrastructure. You can utilize that as well. And then you get all the admin configurations that we as facilitators for the hosted platform get to be able to manage the service. So there are some really nice benefits in that capacity too.
I have another super quick question.
Yes.
We are astronomers, so we use obsolete code that are not supported by anyone else. The typical example is IRAP that up to a few years ago were running only on 32-bit machines.
Yes.
So is that
you have the ability to choose from various Ubuntu images. So if you have an older version of Linux that you'd like to use, you can actually pin old software. So we really try and preserve software. I think for around 4 to 5 years is really kind of its lifetime. Then you'll have to go do a little bit of configuring yourself to make sure that the code's working, but we can give you a really nice basis to get started with. So that way you're not starting from scratch and really trying to go and reinvent the wheel. You at least have some software that you're able to pin, and then you can use some of those older packages from that versioning that you're more familiar with or that you knew that the code actually ran with.
you have a question from online, Mike?
Oh my.
Yeah, hi, I just wanted to respond to the last point. Blake didn't show it, and I'm not gonna try a demo right now, but I do have an IRAF kernel that runs under CoCalc. And with the X11 graphical interface that he talked about, you can actually run IRAF in a terminal in an XG term and display to an XM tool or a DS9. So you have that full environment as well. I can see if I can get a bit. I have a picture of it, a screenshot of that running. I'll see if I can find that, but IRAF is no problem on this platform. We actually, in Data Lab, we even have an IRAF kernel running Gemini data reduction packages.
Great to see you, Mike.
Hey, Blake, awesome demo.
Thank you.
So we'll have to give the room back to the next activity. It was a pleasure having you once again. Thank you for visiting us, and thank you for coming.
Thank you all very much for your time.
Thank you for coming in.